All right, welcome back. Okay, so today we'll be looking at past questions on projectiles. Okay, and we have a couple of them here to solve. So as usual, our advice that you can just get the PDF of the questions, try to solve them on your own. Okay, and then you can come back to compare what you've done with what we have done to make corrections where necessary. All right, so let's move to solving our first question. So number one, we have the horizontal component of the initial speed of a particle projected at 30 degrees to the horizontal is 50 meters per second. If the acceleration of free fall due to gravity is 10 meters per second squared, determine its 1. Initial speed, 2. Speed at maximum height reached. So first of all, we have theta to be 30 degrees, and we have our velocity to be 50 meters per second. But if you look closely here, you see I have ux written here. All right, ux there stands for the horizontal velocity. So if you look back at the question, you will see that we're told here that the horizontal component of the initial speed is 50 meters per second. Okay, which means, okay, first of all, before we move on, let me just try to make something very clear. Okay, when we have object moving as projectiles, you know projectiles follow a parabolic shape, their path. So let's say, for example, we have an object moving through this path, okay, as a projectile. Now, at every point in time, let's say the object is down here. At every point in time you find this object along this path, this object has a tangential velocity. All right, a velocity tangent to this path, okay, which is the velocity of the object, so we can call that u. All right, now this velocity has a horizontal component to it, all right, which I have called ux. Okay, which I have called ux, and it also has a vertical component, all right, to itself. Okay, which I can call uy. Okay, so we have that as uy. So basically, we have been given this horizontal component to be 50 meters per second, all right, from the question. So we're supposed to find u. We're supposed to find the initial speed, which is the speed with which it started moving along this parabolic path, which is our u, that speed that is tangential to the path. Okay, so to find that u, okay, we can find that by, remember what we said concerning resolving vectors into their horizontal components. Okay, we can do that by the formula, that vector cos theta, okay, where theta is the angle the vector makes with the x-axis. And of course, we're already told that this particle is projected at 30 degrees to the horizontal. Okay, so we know our theta is 30 degrees, so we can do u cos 30 degrees, okay, and that will be equal to 50 meters per second, where 50 meters per second is the horizontal component of the velocity ux. All right, so this is us replacing this ux with 50 meters per second. Now, so if we do this, of course, we're going to have, if we make u the subject of formula, because we're looking for u, we're going to have 50 meters per second divided by cos theta, which is 30, so cos 30. Okay, so if we do this, we're going to have our answer as 57.74 meters per second as the value for u, initial velocity. Okay, so we're also asked to find the velocity at the maximum height. Okay, so if we come back to this little diagram I drew here, we can have our maximum height at about this point. So if we draw a line down, we'll be considering this place as the height, okay, of that point. All right, so we have this as the plane of the starting point. Okay, now we're asked to find the speed of this object at this point. Now, projectiles is also a study of motion. Okay, so projectiles is us studying objects that travel in a parabolic path and to try to understand how they react to their environment. Okay, so But normally, okay, so it's still good for us to remember that they are the study of projectiles is still the study of motion. That being said, it means that the formulas we have for motion would also function and work for projectiles in certain conditions. Okay, especially the ones we had for uniformly accelerated motion will still work for projectiles at certain instances. Okay, so I need us to have that behind our minds. Okay, so now looking at this projectile, okay, we are asked to find the speed at this point, which is the maximum height. It's very important for us to always remember that the vertical velocity of a projectile at the maximum height is always zero. Okay, because we remember that when we throw an object up, you throw an object up, okay, from, let's say you throw it out of your hand upwards, the object will ascend horizontally, the object will ascend vertically upwards until it gets to its maximum height, and it will stop for a couple of split seconds before it starts heading back down. Okay, and that's because as the object moves upward, gravity acts on it to pull it back downwards. So the object overcomes gravity up until the point where it can't overcome it any further, and it stops for a split second and then starts coming back down. Okay, so at that point, okay, at that maximum point, the vertical velocity obviously becomes zero. So if this is the object that is thrown upwards, okay, at this point where it stops just before it comes down, of course vertical velocity becomes zero at this point, because of course there's vertical velocity as it moves upward, but once it gets to this point, that vertical velocity becomes zero just before it starts coming down. Okay, so it's the same thing with projectiles. Remember, the velocity of this projectile has a vertical component to it and has a horizontal component to it. So if we consider the vertical movement of this projectile, we'll find out that it started from this point, moved upwards up to this point, and then it stops for a second before it starts coming back downwards. Okay, so at this point, that vertical velocity is equal to zero. Another thing we need to note about projectiles is the horizontal velocity of a projectile does not change during its travel. Okay, the horizontal velocity of a projectile is constant, except for sure it is stated that there are resistances. Of course, normally, naturally, we have air resistances against the projectile. The air resistance and other resistances could reduce the speed of the projectile as it continues its motion. Okay, but in this case, we are assuming an ideal situation where we have no resistance whatsoever on the projectile except the forces we are considering, which is the force of gravity, you know. Okay, so the force of gravity does not affect it at all, because the force of gravity affects vertically and does not affect horizontally. So the horizontal component of the velocity of this particle remains constant till it lands back on the floor. Okay, what changes is the vertical component, and what makes it change is the effect of gravity, okay, pulling on it. So it's that gravity that pulls on it till it gets to this point, stops, and starts coming back down, and gravity doesn't leave it until it brings it back to the ground. Having said that, okay, we can move on. So we'll see that the Vy at maximum height, that's the velocity, that's the vertical velocity at maximum height, is equal to zero. Okay, but then we also know that the horizontal velocity at maximum height is equal to the initial velocity. Okay, because the horizontal velocity doesn't change throughout its journey. So if we do that, then we have our Vx at maximum height to be 50 meters per second. So the second question states, a tennis ball projected at an angle theta attains a range r equal to 78 meters. If the velocity imparted to the ball by the racket is 30 meters per second, calculate theta. Okay, so let's bring out our parameters. We have range to be 78 meters, we have initial velocity to be 30 meters, and we're to find theta. Okay, so this is a straightforward one. We could just use the formula which was given during the class to solve. Okay, we have a formula for range, which is u squared sine 2 theta all over g. Okay, so if we bring in our parameters given here, we would have, of course, u is 30 meters per second. Okay, so we have 30 meters per second squared times sine 2 theta. So we're dividing this by gravity, which is 10 meters per second squared. So of course, the range we're given is 78 meters. So this is just us bringing the value of range here. So r is equal to 78 meters and is equal to this. So we take out this part of this equation and we try to find theta. Okay, so of course we make sine 2 theta the subject of formula. So this is going to be 78 times 10 meters per second squared divided by 30 meters per second squared. Okay, of course meters per second squared would handle meters per second squared here. So we have 78 times 10 divided by 30. All right, and that will give us 0.867. Okay, so once we get, so what we have is sine 2 theta is equal to 0.867. so we make 2 theta the subject of formula. We're going to have 0.867 arc sine. So we're going to be finding arc sine 0.867, which if we do, we're going to have 60. Okay, so we have 2 theta equal to 60. So we can make theta the subject of formula, and we're going to have 60 divided by 2, which is 30 degrees. Okay, so that's theta. So it's pretty straightforward. So let's look at the third question. A projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 30 degrees to the horizontal. Calculate the time taken to reach the maximum height. Of course, we're given gravity to be 10 meters per second squared. Okay, so first of all, let's list out our parameters. We have initial velocity to be 300 meters per second. We have theta to be 30 degrees, and we're asked to find the time it took to get to the maximum height. Okay, so let's remember that we're given a formula, okay, for time of flight. But the time of flight formula we were given is for the full duration of the flight of the projectile from its starting point to its ending point. But here we're asked to find the time it's going to take for it to get to the maximum height, which means we are supposed to divide whatever we get from that formula by 2. So basically, the formula we have for the travel time of the projectile is 2u sine theta over g. So if we just divide this formula by 2, of course, it will cancel this 2 here. We'll be left with u sine theta all over g. Okay, so, but since we are not considering full flight, but half, we'll use this. Okay, and I had just explained to you why. Okay, so, of course, this is for the full flight of the projectile, while this is for half the flight. Okay, so if we bring in our parameters here, we're going to have, of course, u is 300 meters per second times sine theta, which is 30. Okay, 30 degrees to the horizontal. Okay, we divide it by gravity, which is 10 meters per second squared, and then we'll find out our answer is 15 seconds. So that's also pretty straightforward. Let's go to the fourth question. Okay, it says a tennis ball is projected horizontally from the top of a vertical cliff 50 meters high with a velocity of 10 meters per second. Find the time to take the ball to reach the ground. Of course, we're giving gravity to be 10 meters per second squared. Okay, now there are certain things I want us to take note of whenever we're solving projectile questions. You look at the question carefully. It says a tennis ball is projected horizontally from the top of a vertical cliff. So we're not going to have a full normal parabolic path that a projectile will have, because this object is projected horizontally, okay, and it falls off this way. So this goes to make us understand that we're not dealing with a projectile that goes through the normal parabolic path, okay, where you have it probably shot from the ground and it goes all the way up and comes back all the way down to a starting point, the starting plane. Okay, now we don't have this kind of situation. Okay, what we have is quite different. So the object is shot horizontally, okay, from the top of, you can assume there's a cliff here, all right, and we're asked to find the time to take the ball to reach the ground here from the cliff. Okay, so if we bring out our parameters, we have h to be 50 meters. That's the distance from this point of projection down to the ground is 50 meters high, all right, and then our velocity is 10 meters per second. But this velocity, of course, is the horizontal velocity because it was projected horizontally. Take note of that. Projected horizontally means it was projected in this horizontal direction. It wasn't projected at an angle. Okay, it was projected straight on the x-axis. So to find the time of flight, this is going to be quite a simple one, but tricky, because of course we have this guy come from here down to this place. So you can see that we can just consider the vertical motion of this projectile, okay, to get our answer. So if this is our starting point, so we have u as initial velocity and we have v here as final velocity, okay, and from what we know about vertical motion, all right, we know that if you release an object from a point high above the ground, that object will start out at the zero that object will start out at zero velocity, okay, and then would get its highest velocity just before it hits the ground. Now this object was shot horizontally, which means it has a horizontal speed which is 10 meters per second, but it had no vertical, the speed has no vertical component, it only has a horizontal component. So obviously the vertical speed at this point is 0, and it's going to hit maximum vertical speed just before it hits the ground. Okay, so since we know that, we can use that information to just find the time it's going to take this object to go from this point to this point. So let's try to apply one of the formulas of motion, which is v equal to u plus 2gh. Okay, plus because this object is moving in line with the force of gravity. So in this case, we're considering the y component of the velocity. So we have vy squared, okay, equal to uy squared plus 2gh. So at this point, the vertical velocity is 0. The initial vertical velocity is 0. And the final velocity just before it hits the ground is what we are going to find from this equation. And then when we get that final velocity, we now use it in another equation to find how long it's going to take it to hit this ground. So we put in values into the equation. Of course, initial velocity is 0. Okay, so 0 plus 2gh, which is 2 times 10 times 50, and we're going to get that to be 1000 meters per second. But then we have to find the square root of both sides so we can get to know the value of vy. So we're going to be finding the root of 1000, which will give us 31.6 meters per second. Okay, so now we have our final velocity just before it hits the ground to be 31.6. So now use this final velocity to find the time it will take it to move from this position to this position. So we have to apply the formula v equal to u plus gt. Okay, we're still dealing with the vertical components of the velocity. So of course our vy is 31.6, our uy is 0, and we have g. Okay, so we bring that in, 31.6 equal to 0 plus 10 meters per second times t. So we try to make t the subject of formula. Of course, this is like saying 31.6 equal to 10 times t. So we divide both sides by 10 meters per second, and we're going to have 31.6 divided by 10, which will give us 3.16 seconds. Of course, this meter cancels 1 meter, and then this second cancels 1 second here. Okay, so leaving us with 1 per second, which of course, if we move up, it becomes 3.16 seconds. So that's our final answer for number 4. So let's move on to number 5. Okay, number 5 says, at a birthday party, the celebrant pops a corked fruit wine. Okay, if the cork shoots out of the bottle at an angle of 40 degrees to the horizontal and travels a horizontal distance of 4.5 meters in 1.25 seconds, calculate the initial speed of the cork. So you see there's too many activity going on here with trying to describe what exactly happened. So let's pick out our parameters, okay, to make it easy for us to understand the question we are being asked. So theta is 40 degrees to the horizontal. The cork moves out of the bottle at 40 degrees to the horizontal. Okay, then we also have that it travels a horizontal distance of 4.5 meters, horizontal distance, and then it made that journey in 1.25 seconds. We're asked to now find the initial speed of the cork. So like I said earlier, every object that goes through this kind of motion at every point in time along the path has a horizontal component of its velocity, has a vertical component of its velocity, and also has a tangential component of that velocity. So in this case, we're asked to find the initial velocity, and that initial velocity obviously is a tangential velocity because that's the velocity it starts with. So of course, in this case, we have this horizontal distance which has been given to us already, okay, and we have the time it took to cover that distance, okay. So what we are left with is finding the speed. Obviously, we could solve this using a very simple formula, which is speed equal to distance over time. So let's consider the horizontal speed of this particle, okay, that's the cork. Let's consider the horizontal speed. Of course, the horizontal speed is u cos theta. So we're going to have u cos theta equal to distance over time, okay, because we're considering only the horizontal now, okay, because we want to find, of course, u. So we have distance, we have time, we have theta, we make u the subject of formula, okay, and we're going to have distance over time times cos theta. All right, so if we bring in the parameters into this, we're going to be having 4.5 divided by 1.25 seconds times cos 40, because that's the angle it makes with the x-axis given to us here. So if we simplify this further, we're going to have our answer as 4.7 meters per second. Okay, so let's move on to the sixth question. The angle for which a projectile must be fired to cover maximum range is dash. Of course, we're taught this. The angle it needs to have is 45 degrees, and that's because the formula for the range has, of course, we had used it previously to solve the question, and that formula is u squared sine 2 theta all over g. Okay, so let me just try to write that down. Sine 2 theta, and we have everything over g. Now if this theta is 45, it means we're having sine 90 degrees, okay, because 45 times 2 obviously sine 90, and sine 90 would give us 1. Okay, sine 90 is equal to 1. Okay, so if we have 1 here, so we have u squared all over gravity. So you see that will give us the maximum range that we can cover, okay, with that projectile. Considering the speed it's going on, that would be the maximum range it can cover. So our answer is 45. Okay, so let's look at number 9. All right, so we have a stone thrown horizontally with an initial velocity 15 meters per second from a tower 20 meters high. How long does it take to reach the ground? So this is the horizontal component of our velocity. That's the initial velocity. Okay, so bringing out our parameters, we have ux is 15 meters per second and uy is obviously 0. So at that point where it's projected, the vertical velocity is 0. The horizontal velocity is 15 meters per second. Okay, because it was horizontally projected, it has no vertical component. Then our h is 20. So what do? We get a formula that can give us all these parameters while we try to find the time. But before we get to the time, we have to first of all find the final velocity just before it hits the ground. Then we use that same formula to move forward to find the time. Okay, so we're using v squared equal to u squared plus 2gh like we did previously. Okay, but the y component of these velocities. Okay, so that will give us 0 for our final velocity. Okay, so we have this formula v squared equal to u squared plus 2gh, and of course from what we can see, our initial velocity for the y-axis is 0. Our initial vertical velocity is 0. So we have 2 times g times h, which is equal to vy squared. So that will give us vy squared is equal to 400. Then we find the square root of both sides. We'll have vy equal to root 400, which is equal to 20 meters per second. So what do we do with this now? We now use it to go find the time taken for it to do this journey. So to do that, we use another formula, v equal to u plus gt, where we have our final velocity as 20 meters per second, initial velocity as 0. Of course, remember we are considering the y components, okay, the y components. So we have 10 meters per second squared for gravity. If we simplify this, we're going to get t as sort of the formula. Of course, then 20 meters per second divided by 10 meters per second squared, which will give us 2 seconds.